Good afternoon, everybody. Let us start. Okay, so today we will start. Today, what we will learn problems based on. Today, we will see problems based on complex integration. Okay, so now in last class we already know how to find the length of a curve or how to find the complex integration. Now we will do some problems. So let the first problem be evaluate integration over C f of z dz, where f of z is equal to y minus x minus I 3x square. Okay, and C is the line segment from C is the line segment from z equal to 0 to z is equal to 1 plus I. Okay, now we will find its solution. Or we have to find what is the integration over C f of z dz, and f of z is your y minus x minus I 3x square, and C is the line segment from z equal to 0 to z is equal to 3 plus y. So how we will do this type of problems? So you have to find the line segment. In our first step, we have to find the line segment which joins z equal to 0 to z equal to 1 plus y. So what will be the line segment that joins these 2 points? Your C means this is equivalent to your R square. Okay, so let this is by R2 or this is C, and z equal to 0 means this is 0 0, and z is equal to 1 plus I means suppose this is in real part this is 1, this is 2, and in imaginary axis this is 1 and 2. So what is 1 plus I? This will be somewhere here. So this is your 1 comma I. So what is the line segment joining this thing? This will be the line segment joining this one. So now this is the point. You can say this is the point 1 comma 1. Okay, 1 plus I means this is 1 from real unit or 1 from real axis and 1 unit from imaginary axis. So this is 0 0 to 1 1. Then what is the line segment joining? Suppose this is your x1 y1. Okay, and this is the point x2 y2. And we know what is the line segment from the coordinate geometry. We know the line segment joining these 2 points must be, this is y minus y1 whole, y minus y1 is equal to slope whole into x minus x1, or you can say this is y minus y1 equal to, what is the slope? This is y2 minus y1 divided by x2 minus x1 whole into x minus x1. So this is your x1 y1, this is your x2 y2. Then what will be my line segment, or what is the this thing if I will put x1 y1 x2 y2 in the above formula? So y minus y1 means y minus 0 will be y2 minus y1, this is 1 minus 0 divided by 1 minus 0 whole into x minus x1 is your 0. So this will be y is equal to x. So this is the line segment y is equal to x. This is the line segment which joins z equal to 0 to z is equal to 1 plus I. And then here if y is equal to x, now here we can say here the line segment that joins z equal to 0 to z is equal to 1 plus I is given by y is equal to x. Okay, and you see here if y is equal to x, so what will be the single parameter? If I will convert this thing into a single parameter t, so I can write the parametric equation for curve C is given by x is equal to t and y is equal to t. So for parametric equation means I have to convert it into a single parameter t. So if I will assume my x is equal to t, so since y is equal to x, so y will be t and t varies from, say here x varies from 0 to 1. I am taking first x is equal to t. So here x varies from 0 to 1 or y varies from 0 to 1. So t must vary from 0 to 1. So this is the important thing you have to calculate. What is the parametric equation of the curve? And in this parametric equation, we have convert that two variable into a single variable in terms of t. Okay, and here t varies, x is written in terms of t and y is written in terms of t, and t varies from 0 to 1. So after doing this thing, then what will be your z or your z of t? Z of t is that x plus iy or x of t plus iy of t. Then x of t means x is t, then this is it. Then what will be your z dash t? Z dash t, this is t plus it. Then its derivative with respect to t is, this is 1 plus I. Then what is your f of z? F of z is your y minus x. This thing is given to you, y minus x minus I 3x square. So this will be t. In place of x you will write t, in place of y you will write t. So this is t minus 3i t square. So t can cancel out, then it will be only minus 3i t square. Okay, so after converting all this f of z, z of t and z dash t in terms of t, now I will evaluate my integration over c f of z dz. Okay, so now integration over c f of z dz can be written as, this is f of z. F of z is just this one, minus 3i t square minus 3i t square. Then f of z, how we are evaluating this thing? Let I write one step more. So we know already integration of f of z dz is equal to, this is f of z of t, z dash t dt, and t varies from, here we saw here t varies from 0 to 1. Okay, so this is t from 0 to 1, and your f of z of t is your minus 3i t square. Then z dash t, this is your 1 plus I, and then dt. So here take the constant terms to outside of this integration. Here 3i minus 3i, and here 1 plus I. So this is minus 3i whole into 1 plus I. Then integration of t square is t cube by 3. So in a single step I did this one. You may extend one step. So this integration of t square is t cube by 3. So and its limit of integration is from 0 to 1. So this will be minus 3i whole into 1 plus I whole into, this is 1 by 3 minus 0 after putting the limit. So this will be 1 by 3. So 3 can cancel out. So only what will left, minus I whole into 1 plus I. Okay, so what is minus I whole into 1 plus I? So minus I into 1 minus I, and minus I into I is minus I square, which is 1. So this will be 1 minus I. Okay, you can see it. Then comes to another problem. Problem number 2. Prove that integration over c dz divided by z minus a to the power n, and this one is 0 if n not equal to 1, and this is 2 pi I if n is equal to 1, where c is the circle, where c is the circle with center a and radius r, with center a and radius r, and n belongs to z. Okay, so how I will do it? So first we will write the parametric equation for c. So parametric equation means we have to convert the equation of the curve in a single parameter t. Okay, and you know what is c is here. C is the circle whose center is a and radius is r. That means C is a circle whose center is a and radius is r. That means z minus a modulus equal to r. This implies if I will remove this modulus, I can get z minus a is equal to r e to the power it, where t varies from 0 to 2 pi. Okay, since it is a complete circle, so this is the equation of the curve. Okay, so what will be the parametric equation of this curve? See, the parametric equation of the curve C is given by, of the curve C is given by, so if I will introduce t, then this will be, this here only a single variable is there, so you can write this is the parametric equation of t is, this is z minus a is equal to r e to the power it, where t varies from 0 to 2 pi. Okay, so this is the equation of the curve in parametric form. Now go to our problem. This is integration over c, so dz divided by z minus a to the power n. So, and we know here f of z is this one. This is integration over c 1 by z minus a to the power n. This is your f of z. Then we will write what is z dash t. Uh, I will write this thing as, this is your f of z of t, z dash t dt, where f of z of t is, and your f of z is 1 divided by z minus a to the power n, and in place of z minus a I will write this is r e to the power it. Then what will be this one? This is 1 by r to the power n, and e to the power it means this is e to the power I n t. Okay, this thing to the power n. So f of z of t is this one. Then what will be your z dash t? If z is your this one, so what will be its derivative? This will be only r e to the power it into I. So this will be your r dash t. So, and here t varies from 0 to 2 pi. Okay, so I will put here t varies from 0 to 2 pi, and f of z of t is your 1 by r to the power n e to the power I n t, and z dash t here I r e to the power I t, then dt. Then then what I will write in the next step, here this is r, here r to the power n, so I will write 1 by r to the power n minus 1, and here I is also here, so I am taking this constant to outside of this integration, then this will be I divided by r to the power, this is n minus 1. Okay. Then integration from 0 to 2 pi r, what is left here, this is e to the power I t, this is e to the power I n t. So this will be e to the power I whole into, this is 1 minus n t dt. Okay, now take its integration. This is I divided by r to the power n minus 1, and then integration of this one is, this is e to the power I whole into 1 minus n t divided by I whole into, this is 1 minus n, and its limit is from 0 to 2 pi. Then this is I divided by r to the power n minus 1 whole into, then in place of t if I will put 2 pi, then this will be e to the power I whole into 1 minus n 2 pi divided by I whole into 1 minus n minus, in place of t if I will put 0, e to the power 0, that will be 1 divided by I whole into 1 minus n. So if I will take this thing common, r to the power n minus 1, and then this 1 by I whole into 1 minus n, then only this thing left, e to the power I whole into 1 minus n 2 pi 1, and if you find this one, this is your 1, because we know e to the power I theta is your cos theta plus I sin theta. Okay, so if you use this formula, then you will get this value is 1, so this is 1 minus 1 will be 0, then 0 into this thing will be 0, so this is your answer. Okay, if this is n not equal to 1, if n not equal to 1, because here you are getting after integration, this is 1 minus n, so if n is equal to 1, then this fraction has no meaning. So for n not equal to 1, for n not equal to 1, this is the value, and for n is equal to 1, for n is equal to 1, the integration will be integration over c, this will be dz divided by z minus a, and which is 2 pi I, this thing we already calculated in my last class. Okay, you can see it. For n is equal to 1, this thing can be written as, in place of n if I will write 1, then this will be integration over c dz divided by z minus a, and this thing is already calculated, this is 2 pi I, and here c is a circle whose center is a and radius r. This thing I already calculated in my last class. Okay, so now comes to another problem. So evaluate integration over c mod z bar dz, where c is the closed curve consisting of, where c is the closed curve, c is the closed curve consisting of the upper semicircle, consisting of the upper semicircle consisting of the upper semicircle. mm, consisting of the upper semicircle not only this space. So this is your problem 3, and this is saying evaluate integration over C mod z z bar dz, where C is the closed curve consisting of where C is the closed curve consisting of C is the closed curve consisting of the upper semicircle consisting of the upper semicircle consisting of the upper semicircle mod z equal to 1 on the segment x lies between -1 to 1. Okay, I have to evaluate this thing, this integration over curve C, where C is the closed curve consisting of the upper semicircle mod z equal to 1. You know mod z equal to 1, this is a circle whose center is 0 and radius is 1. If I draw this thing, suppose this is my 1, this is -1, and this is 1, this is -1. Okay, so mod z equal to 1 means this is a circle whose center is 0 and radius is 1, and I am saying its upper semicircle. So this is a semicircle means this is half circle and only its upper part we will consider. So this will be this thing whose center is origin, center is 0 0 and radius is 1. Okay, so this is the upper semicircle. Okay, so let this one be your C1, and here this is your segment C2. Let this is your segment C2. This is the line segment, just a line. If you use another color, then you just see this is the segment. This is the segment C1. Okay, in this direction, and my C2, this is from -1 to 1. Okay, so this is the -1, this is -1 to 1. Up to this one, this is your C2, and I have to evaluate. This is your f of z. Your f of z is mod z z bar. So here f of z is this one, and this is the curve C1, and this is the curve C2, and so the C consists of C1 plus C2. So now comes to our problem. So what will be my solution? Here curve C is equal to C1 plus C2, where C1, this is the upper semicircle, C is the upper one semicircle, and C2 is the line segment or the segment where x varies from -1 to 1. So now what will be the equation of C1, or what is the parametric equation of C1? So I can write for C1 mod z is equal to 1, that means z is equal to 1 e to the power it. Okay, if I will remove this modulus, I will write e to the power it, where t varies from, in generally there is 0 to 2 pi, but here it is saying that upper semicircle, that means only the upper part, so t will vary from 0 to pi. Okay, so z is your e to the power it, and t varies from 0 to pi. So what will be the integration of C1 of this mod z bar dz? So if I will convert this thing into in terms of t, so here t varies from 0 to pi, and what will be your mod z? Mod z is 1, it is saying already, and z bar. So what is z here? Z is your e to the power it. So what will be your z bar? Z bar is your e to the power minus it, and you know uh, what will be your z dash t. So if z is your this one, then what is its derivative with respect to t? Then this will be I e to the power it. So if I will put this thing here, in place of z mod z, I will put 1. In place of z bar, I will put e to the power minus it. Then in place of z bar, sorry, z bar I already written. Then dz means z dash t dt. So in place of z dash t, I will write I e to the power it dt, and t varies from 0 to pi. So what will be its value? This is integration from 0 to pi. This is e to the power minus it. This is e to the power it. Then this will be 1. Then I can go outside of this integration. Then I into 1 dt. So this is I. Then integration of 1 is t, which varies from 0 to pi. So this will be I pi. Okay. So integration over C1 is your I pi. Similarly, what is integration over C2? For C2, C2 is your line segment which joins x from -1 to 1 only. So for C2, what I can write? What is the equation of C2? Equation of C2 is z is equal to, for equation of C2 for this line segment which joins only -1 to 1. For that thing, you can write y is equal to 0 and x is equal to t, where t varies from -1 to 1. Okay. So your z would be x plus iy, so iy is 0 and x is t, so you can write your z is equal to t only. Okay, z is equal to t and your t varies from -1 to 1. Then what will be your mod z? Here mod z, mod z, this will be minus t because z is equal to t here. So mod z will be minus t if t lies between -1 to 0, and this is simply t if t lies between 0 to 1. So this will be your mod z. Similarly, you know, so mod z value is this one when t lies between 0 to minus 1 to 0, and this value mod z is t if t lies between 0 to 1. So if I will take its integration over c2 mod z z bar dz, this one will be, I will take this thing from -1 to 0, then 0 to 1. So in -1 to 0, what will be your mod z? Mod z is minus t, so this will be minus t, you can write this is minus t, and in place of z bar, so if what is z bar? Okay, if z is your t, then your z bar will be t because it has no imaginary part, so this will be t. Okay, so this will be your t. Then dz means z dash t dt. So if z is your t, then what will be your z dash t? This will be 1, so this is 1, then dt. Similarly here, this will be mod z is equal to t in 0 to 1, this is t, and then z bar is your t. Since z is t, so z bar is also t. Okay, z bar means the conjugate of z, so this will be t because its imaginary part is 0 here, so t, then, and if z is your t, so z dash t is 1, so this is 1, then dt. Now you just take its integration, this is -1 to 0 minus t square dt, and then this is 0 to 1 t square dt. Then minus t square, then what is it integration? This is minus t cube by 3, this is from -1 to 0, and this is t cube by 3, and this is from 0 to 1. So if you evaluate this integration, what you will get? This is 0 minus, or you can say, you can take this minus outside of this integration. This minus you can take outside of this outside, then this is minus of 0 minus 1 by 3, and for this one, this is 1 by 3 minus 0. So what you will get here? This is minus 1 by 3, and this is then plus 1 by 3, then this is 0. So integration over c2 is 0, and integration over c1 is I pi, and since c is your c1 plus c2, so integration over c, whatever is written f of z dz, this, since my c is c1 plus c2, so integration over c means this is integration over c1 plus c2 f of z dz, that means this is integration over c1 f of z dz plus integration over c2 f of z dz, and we individually calculated what is integration over c1 and what is integration over c2, and this is I pi plus 0, then this is I pi. So this is your answer, I pi, or you may say this is pi I. Okay, now comes to another problem, just that will be your last problem. So let the problem be, so that integration over C mod z square dz is equal to minus 1 plus I, where C is the square with vertices, where C is the curve C. Okay, the C is the square. C is the square with vertices O whose coordinate is 0 0, A whose coordinate is 1 0, B whose coordinate is 1 1, and C whose coordinate is 0 1. C whose coordinate is 0 1. And as you can see, this is a square. uh, if this is my 2D, this is your 0 0, this origin, and suppose this is your 1 1 means this is 1 0, and this is your 0 1 point. This is your 1 in y axis, this is 1 in x axis, and so this is your origin O. Then this is your point A whose coordinate is 1 0, and point B somewhere here which is 1 1. So this is your point B, and this is point C. So let this one, I will use another color. Let this is your C1, curve C1 which joins this line segment 0 0 to 1 0, that is OA. Then this is OAB. This is your curve C2 or line segment C2 which joins A to B. Then this is your C3. Then this is your C4. Okay, C1 which joins O to A, or the C1 is the line segment OA. Then I can write let C is equal to C1 plus C2 plus C3 plus C4, where C1 as C1 is the line segment joining, or C1 is the line segment OA, and C2 is AB, and C3 is BC, and C4 is CO. Okay, so if these things are like this, then what is the equation of C1? For C1, what I will write for C1, what will be the equation of C1? C1 is the line segment joining O to A. So what will be the equation of C1? What is the equation of C1? Equation for C1 is x is equal to t and y is equal to 0. Set. For C1, equation of the curve is x is equal to t, y is equal to 0, and here t varies from 0 to 1. You just say t varies from 0 to 1 for this line segment joining OA. This is a straight line, so x is equal to t, t varies from 0 to 1, and here y coordinate is 0. So this is the equation for C1. equation of this curve C1, equation of the curve C1, equation of the curve C1. Then what will be my integration? Integration over C1 of mod z bar dz. So x is equal to t, y is equal to 0. So what will be my z? You know z is x plus iy. So this is, and in place of x I will write t, and in place of y I will write 0. So z is equal to t, or z of t, this is your t. Then what will be mod z square? This will be t square. Okay, mod z equal to t. Then mod z square is your t square. Then if z is equal to this one, then what is z dash t? This will be 1. So if I will write this thing, integration over c1, and here if I will convert this thing in terms of t, so t varies from 0 to 1. Then mod z square means this will be t square. Then z dash t dt, z dash t is your 1. Then dt, then what is the integration of t square? This is t cube by 3, and here this is from 0 to 1. So this will be 1 by 3. Okay. Similarly for C2, equation of the curve C2, equation of the curve C2. So see, this is your C2. Okay, and here x is fixed. X is equal to 1 and y equal, here you can write x is fixed and x is 1, and y is equal to t, and see the t varies from 0 to 1. Okay, see here this is 0, and here y is 1, and it is a straight line. That means x is equal to 1 and y, if I will take y equal to t, here then t varies from 0 to 1. Then what will your z of t? This is your x plus iy, which is your 1 plus I t. Then what will be your z dash t? So z dash t will be your, take its partial derivative with respect to, take its derivative with respect to t. This will be I. Then what will be your mod z? If z is your x plus iy, then you know your mod z is x square plus y square, and I am taking x square, x is 1, y is t. So this will be 1 plus t square. Okay. So this is mod z, sorry, mod z square. This is x square plus y square will be, which will be 1 plus t square. So if I will take its integration, integration over c2, this is mod z square dz, and here t varies from 0 to 1, and in mod z square I will write this is 1 plus t square, and dz means this is z dash t dt. So z dash t is I, then dt is this one. So I can take I outside of this integration, then take the integration of 1 plus t square. This is t plus t cube by 3, and limit of integration is from 0 to 1. So if you will evaluate this thing, you will get this is 4I by 3. Okay, after putting this limit from 0 to 1, you will get this is 4I by 3. So first one is 1 by 3, second one is your 4I by 3. Similarly, if you will calculate for C3, now go to next page. For C3, you see this is the curve, this is the 0 0, and this is 1 0, this is 1 1, and this is your 0 1. This is O A B C, and this is the curve C1. This is the curve C2, and this is the curve C3, and this is the curve C4. Okay. Now for C3, what will be the equation of C3? If I will go in this direction, and this is the direction of C4. So the equation for C3, the equation for curve C3 is x. Here x is, let x varies from 1 minus t. and y is fixed, y is 1. On this line y is 1, you can say, you can see it. And if x varies from 1 minus t, and t varies from, say, t varies from 0 to 1. So if I put t equal to 0, I will get this x equal to 1, this point. Okay, and if I will put t equal to 1, then this will be 1 minus 1 0, then I will get this point. So I can go from this point to this point in this direction. Okay, so x is equal to this one and y equal to this one. So your z or z of t, which is your x plus iy, this is your 1 minus t plus 1 1 I. Okay, this is x plus iy. So z of t equal to this one. So what is your z dash t? This is will be minus 1. Okay, then what is your mod z square? Z is this one, so mod z square is your 1 minus t square plus 1 square, which will be, this is 1 plus t square minus 2t plus 1, which will be 2 plus t square minus 2t. Okay, so this is your mod z square. Now what is integration of c3, integration over c3 of mod z square dz. So here t varies from 0 to 1, t varies from 0 to 1. What is your mod z square? Mod z square is this one, 2 plus t square minus 2t, 2 plus t square minus 2t, and z dash t is your minus 1, and then z dash t dt. Okay, so what will be this one? You can take this minus 1 outside of this integration. Then integration of 2 is 2t, then integration of t square is t cube by 3, and minus 2t integration is t square by 2. Then if we will put its limit from 0 to 1, then what we will get? This is minus 4 by 3. Okay. Similarly, for C4, the equation for C4, the equation for C4 is, this is your C4, and here for this line, vertical line, here x is fixed 0 and y is similarly 1 minus t, where t varies from 0 to 1. Okay, if we put t is equal to 0, then y will be 1, the upper point, and if we put t is equal to 1, then 1 minus 1 is 0, this is the origin point, and here x is fixed, x is 0. So what will be your z, or what is your z in terms of t? This will be 0 plus I whole into 1 minus t. This is your I whole into 1 minus t. Then your z dash t will be, derivative of this one, this is minus I. So this is your z of t, this is z dash t. Then what is your mod z t square? Mod z t square is, z of t is this one, 0 plus I whole into 1 minus t. So this is 0 square 1 minus t square, which is 1 minus t square, or you can say this is 1 plus t square minus 2t. So if I evaluate this integration, integration over C4 mod z square dz. So this will be integration over C4, t varies from 0 to 1, so t varies from 0 to 1, and mod z square is here this one, this is 1 plus t square minus 2t into z dash t. Z dash t is your minus I, then dt. So minus I is constant, it can, you can take it outside of this integration. Then integration of this one is, this is t, sorry, this is t, then t cube by 3 minus 2 t square by 2. This is 0 to 1. So if you will evaluate this integration, you will get this is minus I by 3. So now individually we calculated what is the integration over C1, C2, C3, C4, and you know C is C1 plus C2 plus C3 plus C4. So integration over C f of z dz is equal to integration over C1 plus integration over C2 plus integration over C3 plus integration over C4 of f of z dz, and individually we calculated these things. So if we will add them, then integration over c1 is 1 by 3, and integration over c2 is 4i by 3, and integration over c3 is minus 4 by 3, then last one is minus I by 3. So if you will add this thing, you will get this is minus 1 plus I. So this is the final answer. Similarly, if you will get any problem like that, you can solve it. Okay, today only this much. Thank you.